Hi, this is Leetcode question sorting three groups. This is the third question of biweekly contest number 111. To solve this question, we will use a brute force technique. And to do that, assume we have array that has some numbers. And the idea is we want to divide this array into three parts. This is the first part, and this is the second part, and this is the third part. We need to make all the elements in the first part equal to 1, and we want to make all the elements in the second part is equal to 2, and in the third segment all the elements equal to 3. So this is the target. And to do that, let's say we have some counter initially equal to 0. We check every element in the first segment. If it doesn't equal to 1, we just increase the counter, and the same for the second segment. If the elements that lie on this part doesn't equal to 2, we increase the counter, and the same for the third segment. If the number doesn't equal to 3, we increase the counter, and at the end this counter or the result will contain the number of operations we need to make all these segments sorted by making the first segment equal 1, the second one equal 2, and the last one equal to 3. And then we need to check for different combination of segments, so we need to change the length of these segments. So we can try, for example, with this one and this and this. So this is different combination, and we need to find the answer for every possible length or combination of these segments, and at the end we will take the minimum answer. And notice that any of these segments, the length can be equal to 0. The first segment starts at 0 and end at index I. I is not included, so it's from 0 to I. Now if I is 0, the length of segment is 0. That means no numbers lies or will equal to 2 in this case. Second segment, so this is I. The second segment starts from I to j. This is j. I included, j is not included, so it's from I to j. The last segment starts at index j included and end at the last element of the array. And again, any of these segments can equal to, or the length of any of these segments can be 0. Now, how can we try all different combination? Notice here we have I going to this edge, and we have j. So all what we need to do is to play with I and j. If we try for every possible I from 0 to n, and for every possible I also we try all possible j from j equal I to n. By this, when we move I and j, we can have all the combination of different lengths for these three segments, and that means we need for loops to control the length of these segments, and we need another loop to check the value if meet the condition. So if the value is less than, or if the index k is less than I, that means this element exists in the first part of the array, and we need to check if this element, if this nums of k does not equal to 1, because if it's not equal to 1, we need to increase the counter, we need to change it to 1. Else, if the element is not less than I, if it's less than j, that means it exists in the second part of the array, and in this case we need to check if it's not equal to 2 to increase the counter. If not, else, if k is not less than I, if it's not less than j, that means it's in the third part of the array, and we need to increase the counter if the value is not equal to 3, and we take the minimum of answer and result. The answer initially equal to n. This is the highest possible value, which is the size of the array. For example, let's take I, start with I equal 0 in this array, I equal 0, j equal 0. Remove this. So I equal 0, j equal 0, I equal 0 here, j equal I, and so this is I, this is also j, and we set the first segment start at 0 and end at I, and I is not included. So if k less than I, let's start with k equal 0. 0 is not less than 0, so this condition doesn't apply. K less than j, no. The second segment start at j and finish at, or start at I and finish at j, and j is not included. In this case j equals 0, so the length of this segment is also 0. So k 0 is not less than j, so this condition, we move to this one. We need to check if the element is not equal to 3. So in this case, when I equals 0, j equals 0, the first two segments length are 0, and the third segment equal to the size of the array, and we need to check if all elements in this array not equal to 3. So for k equals 0, the number is 1, it's not equal to 0, so we increase the counter by 1. This k now equals 1. Again, k will not equal, k is not less than 0, and k is not less than j. So this condition apply. Nums of k equal to 3. In this case, we don't do anything. Here k equal 2. 2 is not equal to 3, so we increase the counter. For this also, this equal to 3, this is equal to 3. So for I equals 0, j equals 0, the answer is 3, and the 3 is less than the answer, which is 1, 2, 3, 4, 5, 6. So the answer initially equal to 6. Now 3 is less than 6. We update the answer. So we are done with j equal 0. Then we try with j equal 1. And we do this for all possible case. Now k equals 0. 0 is not less than I. So this condition doesn't apply. 0 is less than 1. That means this condition apply, and that means this lies on the second segment of the array, where we need to check if the element doesn't equal to 2. So is 1 doesn't equal to 2? Yes, so we increase the counter. Next, k equal 1. K equal 1. This doesn't apply. This doesn't apply. So we need to check if for this condition item is a 3, so condition doesn't apply. K equal 2. 2 doesn't equal to 3, so we increase the result, and so on. And after that we need to check for j equal 2. When we're done for all possible j, we increase I, so I is 1. Then we try again with all possible j's, and at the end we return the final answer. Time complexity, here we have 2 for loops, so n square multiplied by, here we have another loop n, so time complexity is n cube. And because n, the size of the array, the maximum is 100, this is valid solution.